Yeah, oh, I know.
Yeah.
I noticed you now.
Sorry about the articles here. I've been reading the.
So before we get started, just a few logistics things. It looks like we'll be stuck in this class forever, so welcome to this small space. But you should be able to see the screen easier because you're very close. Very, there's some silver lining. Second logistics thing is we're gonna soon post homework 1. We're gonna try and distribute it on Friday. You can see on the board over there, it'll be due on the 19th. And basically, there's already a vocabulary sheet up on the GitHub under resources, and that kind of has all the things you need to know for the homework. And hopefully, you should be able to get started after today, and after, next Monday, you'll have a lot of the stuff. Yeah.
And for people who are auditing or sitting in, we actually need you to fill out a form to be officially added to the Sakai site. So, and we can go to Valerie's office or Jennifer's office to get the add form or for the auditors.
You have a question, too?
So where is the GitHub link?
Oh, okay. So I may not even made it yet, but you can get there if you just Google McNeil GitHub. Not the best option. I thought I sent it out in an email too, but
There's 2 McNeils. There's 2 McNeils.
oh well, I'm Nathaniel McNeil. Yeah, I didn't make that clear. Just keep clicking until you find the cat.
Yeah.
That's the secret there. So is that, let me know if you have trouble. Oh yeah, Sheldon, do you want to introduce yourself since this is the first time you didn't?
Hi, everyone. I recognize most of you here. My name is Shadran. In the same cohort year with Nat. Glad to see everyone joining us for this pilot, our official R course. I hope we can learn a lot from this class, and I hope you will find this useful for what you will do next.
Cool. So for today, we're going to have basically 2 parts. The first part of the class, I'm going to just talk a little bit about data frames, which is what we'll be exploring today. And this is how R handles data sets. This is a good starting place for getting comfortable just running code and trying out stuff. And I'm just going to talk about what's not obvious, what's different from SAS. And then we're going to do an activity where we're going to inspect the burst data set that we imported last time together. So if you don't have that installed, or you don't have it loaded, I can help you with that in a minute. But basically we're just going to get started with the very basic stuff, just sort of like how do I do proc contents? How do I look at a variable? How do I get basic summaries? And to help you follow along, you're free to either go on your own or follow along with me during that time period. There's a dictionary that's posted on the GitHub under this lecture, and basically this has all of the code pieces that we talked about last time. So things like operators, the equals and assignment arrow, Boolean comparisons, and then it has stuff that we'll talk about today. So if you want to go on your own during that second part of the class, feel free to take a look at this sheet and just try out some of this stuff. Come up with your own questions. But if not, I'm just going to walk you through sort of an example of using all these things, because this is really just helpful to start coding yourself and feel comfortable pretty quickly once you realize how easy some of it is to get started with. So just to give me an idea for later, does anyone not have the burst data set imported into R? Okay, so I can help you during. Anybody else? Okay. Okay, cool. Well, welcome. You didn't miss too much. I just talked about logistics basically. So I'll just actually review how to import data right now, and then I'll go with you individually in a minute. So basically, the easiest way to get data into R is you're going to get a spreadsheet in Excel. You're going to save it as a CSV file, and then you're going to import it using either the menu in RStudio or the read CSV command. So this is only one way to do this, but it's like the easiest way. I always do this if I can. So up here we've got an example spreadsheet that I made in Excel. So I would save that as a CSV. You can see you just use your file save as, and you change the type to CSV. And then once you have it imported into RStudio, you'll see it pop up in the data browser on the right. And you can click on the little waffle here and see the data sheet view here. So just as an example, I'm going to do the one from the lecture. If you really want to follow along with the lecture stuff, feel free to open Excel and type in this or something similar. So all I've done is, open Excel, typed in, the first row is going to be like the variable names. This is just like SAS, right? And then the remaining rows are going to be the values for each observation or each person. So here I've got 3 people with IDs A1, A2, and B1. I've recorded their blood pressure, which is maybe a covariate. I've recorded their prescription, which might be an exposure, RX, and I've recorded their diagnosis code, maybe the outcome. They're both binary. So again, all I would do is I've typed in my data, or I've opened the data from a collaborator. I've made sure that it's in this format, and then I'm going to file save as computer. I'm just going to save this on my desktop, and I'm just going to call it my data. And I'm going to change the file type to CSV, which is, you want the one that says CSV comma delimited. Here it is. All right, so save that. And Excel's going to complain because it wants to use all the fancy formatting features, but you can just say, okay, yes, I know what I'm doing. I don't want to have the cells in different colors. So once you do that, you can pop over to RStudio, and the easiest way is to just use the Tools menu. You're going to click on Tools, and then Import Dataset, and then from Text File. And I'm going to go to my desktop. And here's my data.csv. I'm just going to open it. So R is going to show me what the raw input looked like and then what it thinks I want. This looks pretty good. Usually you don't have to mess with this. SAS has an analogous thing, if I remember correctly. And you're just going to hit import. And here's my data over here, and R has helpfully popped up the data browser. So you'd use the same procedure to load in births if you want to try it on your own. Basically, you're just going to go to the GitHub and get to the data sets, and then click on births.csv, and then you're going to just right-click on this download link and save that somewhere, and that'll basically be the CSV that you'll start with. All right, so again, I can help you during the free time if you can't get that working, but so really, it's pretty easy. There's other ways to do it, but this is the fastest.
What is that birds data set supposed to look like? Because when you download it and you open it up, it looks really weird.
Yeah, it might be the same problem we had.
Yeah, I did. Okay, before I did it, so.
Yeah, it's just a problem with GitHub. It tries to be fancy and ends up not redirecting correctly.
I did it again, and I think it added an observation. It used the
Oh.
actual variable names as an observation.
God, okay.
So,
All right. Well, maybe I'll find a new way to host that file. That I'll just make a Dropbox link or something. Yeah. Yeah, that's true. We can just post it on there. Okay. That'll be sort of an error-proof way to do it. Yeah, I did not anticipate all this stuff. I'd never had this happen before. Okay, so data sets are the same as they are in SAS, but just to orient you to what things are called, here's the Excel file I just put in. I called it my data, so that's the name of the object. Every piece of data in R is called an object, so here I've just named this my data. This particular type of object is a data frame. It has different attributes that are, again, analogous to what you're used to. There's variables with variable names. There's and those are the columns, which also have variable numbers. So, the first variable name is ID, which is also variable number 1, and you can reference either one when you're working on it. And then you also have observation numbers. You can reference those, which we'll talk about how to do. And these are all ways that you can sort of reach into the data set and pull out what you want. Maybe I want to get the average blood pressure. Maybe I want to see what is the outcome of person 3. Well, I need to use these different indexes to try and pull that out, or to be able to pull out what I want. So here's some examples. We saw yesterday the $sign allows you to pull out variables. So if you put the data frame name, $sign, variable name, it'll pull out just that variable and print out what it is. So here at 120, 130, 125. So it kind of goes in the order of the data set. It can be confusing at first because like, oh, blood pressure is going down, but this is going to the side. But the idea is that these are just one-dimensional things. So they sort of have a beginning and an end, and that's in the same direction. So in the data set, the beginning's at the top and the end's at the bottom. When you just print it out, the beginning's at the left and the end's at the right. So again, you can also reference things using these brackets, which we'll explore more in detail in a few minutes. But the general idea of the brackets is they use a row column specification, like you might remember from taking math classes. So here's the sort of general idea. And you can put a number of things in each of these specifications to pull out what you want. If you leave it blank, it pulls everything. So if I want to mirror taking blood pressure by using this type of indexing, I would leave the row specification blank, which basically means take everything that matches. And I would specify the columns as column 2, because it's like the second variable. So you can see it gives me the same output here. If I just want to get one cell of the data set, I can look at a certain position within a variable. So here I'm saying, okay, start with my data, drill down to the outcome variable, the diagnosis, and then pull out a third element. So if I ignore this, I'm going to get, I think it was something like 110, right? So basically, I'm first turning it into this linear object with the $sign. By doing $dx, gives me this, right? And then I'm applying the bracket to say, okay, take the third item. So you'll notice that these brackets can be flexible, and the number of things in them is based on like the number of dimensions that the object you're indexing has. So in the data set, I put in 2. Here, this bracket is applying to the data set. So I'm saying take this data set and then index, row, column. Here I'm actually indexing this variable because it's sort of at the end. And so I'm saying take the third element of the variable. So again, we'll have more practice with this, but the general idea is the brackets are like an indexing system, right? And the type of indexes you use match the type of object. So with the data frame, there's 2 dimensions, 2 indices, row, column. With a variable, or we'll see other examples of this, but with other objects that have 1 dimension, you just need one thing to put in the index. Here's another way I can get out just the cell by using 2 indices, so row, column, 3, 4. Just as an example of how we can be flexible with this, what if I want to sort of take a subset of a row? Well, I can put in a complex specification for row and column, and there's lots more examples of this, but here I'm saying take row 1 in the yellow. So row 1, and then take elements 3 through 4. The colon sort of means through. So 3 and 4. So this would return just these 2 cells in order. So 1 and 1. So that's basically all we really need to explore the data set. So what we're going to do is we're going to use, we've got the data set loaded. We're going to use these type of references, and we're going to feed these into functions to get out statistics and graphs from our data set. And this is really the overall procedure in R, is figure out, okay, number 1, how do I reference what I want to know about? So do I want to know about the blood pressure variable? Do I want to know about everyone who is over 55 in the data set? Do I want to know about, person 2? So you figure out what you want to know about, and then you figure out what to do with the raw data. So today we're just going to feed it into really simple functions like mean, histograms, stuff like that. But this is just gonna expand. You're gonna have more options, and you're gonna be able to do everything you want with data analysis here. So again, I'm gonna walk you through some examples, but feel free to go on your own if you prefer that, or work in small groups. So we're gonna start with, first of all, a very basic approach. So this is what you should try and figure out if you're going on your own. Number one, how many observations variables are there in the data set? Then we're going to look at a variable of your choice. I'm just going to pick gestational age. So we're going to try and get some basic stats on the variable. What's the mean, standard deviation? What's the distribution? How many missing variables are there? And then you're going to basically try and wrap your mind around this type of analysis, which is, if I want to answer a question about a subset of the data, how would I do that using brackets? So in this example, you're going to identify a numeric and a character variable in the data set. And there's a way to do this in the dictionary that's linked at the top. And you're going to try and summarize the numeric variable by the categories of the character variable. So this is really starting what an epidemiologic analysis would be. So we would basically take people who are smokers and not smokers. That's the category variable. And we're going to try and summarize, maybe the amount of time they live, the numeric variable, by that category. And that's going to sort of be starting us towards that 2x2 table that we're familiar with, and other sorts of analyses. Eventually we're going to have models where we have a lot of different boxes that are these cross-reference things by different covariates, and then we're just going to have, some sort of summary in each box, and we're going to use that to build our model. So again, I'll just start out. I've got bursts loaded. The two that didn't, have you got it loaded yet? Okay, you're good. So we're going to start assuming that I've got bursts over here. Just as a reminder, we can click on the waffle to get the data set view. It's a pretty big data set. So when I first get a data set, often I want to know what's in it, right? In SAS, we would use proc contents. The two basic ways I use in R are, first of all, names, which just returns a list of the variables. So names, births. So you'll see I've got a printout over here in the terminal. Does anybody know what these square brackets are? Based on what I just said about what square brackets mean? Yeah. So you're both right. So in the general sense, it's the index of the output, and in this specific sense, it's the column number, right? Because if you think about it, the names of my data set are going across the columns. So what it really means is this is number 1, this is number 3, this is number 5, and you can figure out that this one's going to be number 4 because it's after number 3. R kind of adapts this based on what your terminal looks like. So if I do this again with a wider terminal, you can kind of count out what the index is for something by looking at the starting index. So what would this one be? What's the index of this? Right. So it's 17, 18, 19. So again, this is just R's. It's a way for R to show you a complex object and still have you know what is what in it. So we've got a whole lot of variables here. Here's the names. I might also want to know how many observations and variables I have. RStudio does this for you, but sometimes you want to have an output that reflects that. Let's say you want to run a loop through all the variables. Now there's better ways to do this in R, but you can always fall back to that if you want to. Let's say you have multiple blood pressures you want to add up and you want to figure out how many there are. Well, you can use the dim function. That will get the dimensions of the data set. And this matches the row and column ordering that we're used to here. So again, R is indexing the output. The dim function it outputs a vector with 2 elements. The first element is the rows, and the second is the columns. So if you forget which index is which, you can always use dim to be okay, well the first thing has to be rows because I know I've got 12,000 or 122,000. I know I've got 117 variables. So this is a little bit complicated, but can anybody figure out, using just what we've seen now, how would I get R to print out just the number of variables using dim and brackets?
Bracket, space, comma.
So bracket.
117.
Space comma. Yeah, so we want to get R to reference the 117, right? So I would actually do, so remember, this is sort of one of the leaps of faith in R, but the output can always be input for something else. So I can start with the output that I already made, which is dimmed births, which is here, and I can actually, okay, I want to index this, so I'll put in 2 as the index, right? You can think of everything R outputs as like a tiny temporary data set, and you can always like interact with it here. So if I did dim births 2, I get 117. An easier way to think about this is if I save this as something called dims, so like here I'm actually making it explicit like a temporary object. If I make dims here, well, I can look at dims and see what it is. Okay, it's an integer from 1 to 2, and here's the values. So now I can do dims 2, because dims only has one dimension. It's just the 2 things, and I can get 117. So this is basically everything you're going to be doing in R is building up from little pieces. You're going to build up to what you want. You know, there's not as much guidance. You know, you're free to do it any way you want. You know, just as an example, I think what you were talking about with the 117 was I could do I could pull out one row of births. I could do births. So I take row 1 and then keep everything on the columns. So basically this is saying, okay, take the first observation. So here's person 1, and here's all of their variables labeled. R has a function that returns the length of a one-dimensional object called length. So if I just take the length of this, so how long is my first observation? It's 2 different ways of getting the same question. So 117. So you can either ask, what's the second dimension of my data set, or how long is the first observation? They get to the same place. This should hopefully be another example of how, you know, already we can see there's a lot of ways to skin the cat. But the benefit of this is whatever way you can think about it, you can, yeah.
For your 9.5, can you also do dims square before the 2? Can you put a comma there?
Oh, I think incorrect number of dimensions. So I guess R will tell you if it doesn't match the number. Yeah. So that basically just try it until you get it to work. And that's what I do. Because R will always complain if you ask it to do something impossible. If you ask it to do something that you don't want that is possible, it won't complain. Yeah.
Is that because that's a value and not a matrix, or?
Yeah, that's right. So it's technically called a vector, but that's the idea. So it's not a matrix, so it can't handle the 2 dimensions.
The like row and column, the same way you would in a matrix.
Right.
So like in the environment where I see like data sets, dims doesn't show up as a data set.
Right. Yeah, so for me at least it shows up under values. So values are vectors basically, and data is like data frames. Even they probably should have had this save vectors, but you can think of it as values too.
So what's the int 1, 2?
Oh, good. So this I was trying to skip for now, but it's good that it comes up organically. So int is the data type. So if I well, I'll show you how to get it, but int is the data type, and then this is like the indexing system. So if I look at, I'm just going to make a variable and then show you sort of what it would look like. So if I call sequence, I'll just call it S. I'm going to call this 1 to 10. So we already know that this colon operator kind of creates a list of things. So if I make S 1 to 10, so you'll see 1 to 10. So it's basically telling me that, so here's where it gets confusing. The indexes don't have to be 1, 2, 3, 4, 5, 6, 7, 8, 9. You always want them to be if you can, but they don't have to be. So this is saying the indexes of dims are 1 and 2, but it's representing that as 1 to 2. Here, the indexes of S are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's basically 10 elements, and it's really easy to work with because they're all in order. You know, don't make an object that's indexed by something else. There's probably a way to do it, but don't, you know. For the most part, you're always going to have objects that have, you know, indexes in sequence. And just as another example, let me make, I'm going to copy the built-in letters data set to L. L might be something else. Let me call this let. Just so that I can see let here. So here, again, I've got 26. 1 to 26 is the index, so it's 26 long. And you can see it's a character type here. So it's just a different type of variable. If you want to get that out yourself, I showed you the length command. I can do the length of let, and it's going to give me 26. The other command that's really helpful, and this will always get you unlost, is you want to use class. So class gives you the type of something. So if I find the class of letters, it's going to call it, this object is a character. Okay, so I know what I'm dealing with. If it doesn't say anything else, if it just says character, integer, something like that, it means that it's like a value or technically a vector. So it's basically like a one-dimensional variable if it doesn't say anything else. So we know that this is a one-dimensional character thing. If I look at the class of births, is a data frame, right? If I look at the class of the number 1, that's numeric. If I look at the class of the class function, it doesn't like that. Too much recursion, but there's a way to sort of see that it'll tell you that it's a function. Actually, let me try this. I don't think it likes this thing. Okay, so it tells me the class is a function. So if you have, everything's the same. Like there's no data set names. There's no, function names. It's all like the characters that you put in R can be anything, and you can figure out what something is by using class. While we're here, I'll just show you the in A is the missing marker. So if I look at the class of in A, logical. Not sure why, but that's the missing value. All right, so I think we've got a pretty good overview of how to look at the data set overall, but let's now drill down to a variable and try and look at it more closely. So I'm going to use the $, again, to get inside of the data set. So I'll look at births, $jest. So I always prefer to use the $sign when I can because it makes it more readable, right? If someone else looks at my code, I can immediately see that I'm dealing with a gestational age variable. But if I put a 2 or whatever it is, they'll have to go, okay, well, what is variable 2, right? So always use the system that makes it more readable to yourself and others. Yeah.
Could you remind me what the $sign is? Is it just like a subset, like just
Yeah.
conceptual?
Yeah. So it's so the brackets mean subset by index. The $sign means subset by name. So we'll have all sorts of other objects later, like maps or matrix. I'm trying to think of lists, I guess. So some objects have, in addition to indices, they have like named things you can reference parts of. So data frames are basically just a matrix that also has a naming system on top of it. So, so for example, if we actually build a matrix object, we can still index it like this, but we can't index it with $sign until we basically add labels to it to make it into a data set. So that's all. So $sign just means index by name. And this kind of thing is by index. Any other questions so far? Good. All right. So really, I mean, this will basically be the end, and then we can have some questions. But so next, if you just look at the sheet, well, let me just show you that you can get out a variable here. So if I just run births jest, it's going to do the same thing I was doing before with the little data set. It's just going to print out the whole thing, right? Because I haven't told R what to do. By default, it just prints it. So I've got a whole bunch of gobbledygook. I know where I am because of the indices on the left, but this is really useless, right? But now that I have this reference, I can feed this into the functions that are on the vocabulary sheet and just get out useful stuff, right? So again, I've done step 1, which is figure out what I want. I want to know about gestational age. Now I figure out what do I want to do with it, and that's picking out the function. Yeah.
When you're running things, how are you doing that? The only way
Oh.
I know is to highlight. And
Yeah, you can press, if you press Control Enter, it'll run the line that you're on. Your cursor can be anywhere in the line, and it'll advance to the next line. So eventually you'll be able to step through all your code by holding down Control and pressing Enter a bunch of times. And then when it breaks, you can see where you were in the code. Yeah, you can also highlight stuff. So if I want to just run this line. If I want to run 2 lines, I can run both of these. If I want to run just let, I can actually do that. I can just highlight let and press run, and so you can debug using that system.
There's also another way of doing it. You can put a cursor on the line and just hit the run button. You see?
Oh,
The upper right one.
this thing?
Upper right. It's
Oh, run the current line. Yeah, okay. So you can hit
yeah.
this too. And then there's a source button. You can click on this little arrow here and hit source with echo, and that'll run the whole script at once. That's like the running man from SAS, or running person, I suppose. It's not clear, but probably when it was originally made, it was the running man. But hopefully we've progressed past that. Okay. Obviously we haven't, but we're making progress. Hopefully, that's what I hope. Okay. So again, I was trying to pull up the vocabulary here. So here's some example functions from day 2 that we can use to run a variable. So summary is a good place to start. Summary will give you a basic summary of the variable. So try putting summary around birth jest. And this isn't a technical term. I just talk about it like this. I'll say things like, put this into a function, wrap a function around this, or weird sort of stuff like that. And I'm doing that by accident. There's no technical. The technical thing is I'm putting in birth jest as an argument to the summary function. That's what I should be saying. But just out of convenience, I'll often say, put this into summary or wrap summary around this. So the inside is kind of inside versus outside. If I say it, it just means like farther in the parentheses or farther outside the parentheses. So if I run the summary here, R will give me some basic stats on it. So median, mean, maximum, minimum. A cool thing is R will figure out what to do based on what you put in. So if I put in a numeric variable, it gives me sort of these stats. If I put in a character variable, so the letters value, which was just the letters of the alphabet, if I put this in, it just gives me a different type of thing. So it tells me, okay, well, this is a character, and it's like 26, right? So we'll see there's other types of data, like factors will give you different types of summaries. But that's the basic way to get some stats out. And if I want to get out just one stat, again, the output is input, so I can index the summary. If I want just the minimum, I can say 1. So it says minimum 17. There's other functions to just get these individual things. So if I do minimum of minimum of births, this will do the same thing, just won't be labeled. So you can look in the sheet for a couple examples, but I'm just gonna, it's the infinite abyss of live streaming. I'm just gonna, do a simple plot so you can see how that works too. It's the same. You just take the plot function, or actually here, let's do the hist for histogram. Let's get a histogram of birth jest. Whoops. My biggest weakness is typing. Okay. So if I run that, R will pop up a graph of the histogram. And we'll learn how to make this look better. This is all with the default options, basically. And I think the reason why R popped it up is because my plot window was too small. I think if you make this window big enough, it might plot down there. But it just says, okay, well, I'm not going to, instead of complaining, I'm just going to pop up a window. I might have also set that on my options. I don't remember what I had on this computer, but you'll either get one here or in the plot window. And if you want to, you can save this, as a PDF, which would be my recommendation because that will preserve the vector graphics and make it not get blocky no matter how big you blow it up. You can also do it as a JPEG or a PNG. I would recommend PNG if you don't want to use a PDF. That's the easiest to paste into a document and it will stay fine for the most part. In the graphics lectures, we'll talk about better ways to do this. So basically, you can experiment with feeding in feeding in the variable into different functions here. You can find the total gestational age if you really wanted to. I'll just show you table and then maybe box plot, and then I'll show you how to subset stuff. So if I make box plot, actually let's do no, that's fine. so I can make a box plot, and that's like a box and whiskers plot. Another helpful thing is I can make a table of data set, and it will make a table of all the values. Now, reiterating the, again, the input is output. Well, what if I want to make a graph out of this type of data? This would be like a bar chart, which I think is very similar to the histogram, really, but it's a little bit different because each one has its own.
Can I
Yeah.
ask a question about the table
Yeah,
format?
yeah.
So it looks like the first row is values and the second row is the number of
Right.
observations.
Yeah.
Is that just kind of its default?
Mhm.
It alternates over time?
Yeah. Yeah, that's correct. And so this really looks bad because, it's both numeric labels and, values. But, there'll be ways to make this look a little bit better. But I can actually feed in this table into the bar plot command. And this will be the last one of these examples. So basically, step 1, get out gestational age. Step 2, make a table. Step 3, plot the table using a bar plot. Okay, so here, this is more generic to table objects. Like I can print any kind of table I want, but basically what it's going to do is make the bar height will be the number from the table that we had. Let me just drag this over here. And so like that would be like this, 1609 somewhere. And the label at the bottom will be whatever I had as a label on the graph. So you can make all sorts of, just as an example, if I want to make a plot of the letters data set, well, let me copy this so I don't delete this, but what happens if I put letters inside of the table at the bottom of this expression? Well, I get a really silly bar plot, right? But this is the starting point. All you do is you put in a different variable. Like let's find a real variable to try out. So I'll put names of, actually let me try it. I don't remember if this works or not. Okay, it works. So if you take the summary of the data set, it actually gives you summaries for all the variables. So we can look around for a good looking, so you can see the ones that have these summaries are obviously numeric, right? And then I can tell that, like, for example, this might be breastfeeding or something. This is a character variable. So what if I put in, instead of letters, if I put in births chest. Whoop, nope, births be fed. Okay, so here's my bar plot of this. And again, there's ways to make it look better, but it's you use the same approach for a lot of different things. It's just figure out what goes in, what comes out. So for the final question, I'll just show you really quickly. Is, well, what if I want to compare summaries between different categories, right? So I found a categorical variable, which is bfed, and I found one that's jest. So what I can do is I can combine the row and column specifications with a logical test. And we'll review this later because this takes a while to get your mind around. But basically what you're doing is you're first going to subset the data so you're going to subset one variable based on another variable and then plot it, basically. So to start with, we're going to first write up something that produces the variable we're interested in. So we're interested in gestational age. So birth gest. I can run that and confirm, okay, I'm getting numbers. Now I'm going to subset this. Remember, this only has one index, so I just have to figure out one thing to put in here. And what I'm going to put in is the value of another variable. So I'm going to say birth gest where is how I read the square brackets. It's like a where statement. Birth gest where births $, what was it, bfed? And then I'll use double equals because that's on page 1 of this thing. So here's all the Boolean things you can use in the where brackets. So I'll say where bfed double equals, and then forget what it was, so I'm going to make a table of it. So table verse $be fed. Whoop. Every time. Table birth be fed. Okay. So it looks like in even y. So if I subset this to where this equals in, whoops. Okay. So now I've produced 19934 entries where this is true, which hopefully matches this. There's probably some missings.
Yeah, what prints out is
Oh, it just said, okay, omitted. Okay, so it's actually this plus that. Okay, so that's good catch. So we printed 10,000 and then R gave up and said, okay, well, I didn't bother. Like, what are you doing? You can't want this. All right, so this will produce so this was gestational age where breastfeeding is equal to no. So now I can find the summary of this. Or actually, let's just do mean to make it simpler. Mean. Again, you're gonna keep building up a complex thing. So I'll take the mean of this, and I get 38. Now I'm gonna copy this and change it to be a different. So I've got u. There's more elegant ways of doing this, but this should help you see how it's working. So I run this. I've got there's n, there's u, and there's y. Okay, so there's not very different between the three. So you may be asking, like, why does this work? How can I reference one thing based on the value of another thing using the square brackets? So the trick is the square brackets have a second functionality. So before I talk about how you can put in an index, you can actually also put in a list of true-false values to say whether you want the observation or not. So let's start with our S. Remember what S was? It was just 1 to 10. Actually, let's make something called K that just is 1 to 3 because I don't want to type out something that long. So here's K. It's 1 to 3. If I take K, true, true. So what C does, C will combine these true-false values into like one type of variable. So if I just run C, object not interpretable as factor. What if it's lowercase c. How many of errors? Okay, so C is now true. Another way to think about it is if I make a variable called keep, this could help you think about it maybe. So basically you're saying, okay, which observations do I want to keep? If it's true, I'll keep it. If it's false, I'll not keep it. So I'll put true, false, and then make this the same. So I'm showing you two approaches to how this works. So if I take K and I say, okay, give me the first observation, give me the second observation, and don't give me the third observation, you get 1 and 2. And analogously, if I say K, and then you can feed it keep, which is the same, it has the same value as this. So you're saying, okay, well, keep is a variable that says which ones do I want to keep, and I run that, I'll get 1 and 2. So all that this where statement sort of is doing is saying, let me just run this to show you. This is generating a list of true-false values, right? So for example, observation 9996 comes out true. This value was true, so it matches in, so it does have an in value. And this observation 9991 is false, so don't include that one. So what you're doing is, this is giving you true-false values to tell you what to include. When you apply that to births, it subsets the data based on another variable, and then you can then feed that into mean. So this is sort of the really hideous manual way to do it, but this is always happening behind the scenes. So if it doesn't make sense to you, we'll have a lot more examples, but if it does make sense to you, great. See if you can help explain it to others, because this is really essential, but we'll have lots of time to work on it. So any questions about the stuff today? I think that's, yeah. So C just basically lets you build a custom variable. So like if I do C, A, be, so yeah, it's concatenate or combine. So it basically just puts them together. So like if I wanted to build letters, I would just keep doing this all the way to Z, and then call it letters. Yeah, so C builds just custom, and we'll talk about C next time. I actually didn't mean to do it today, but C is sort of one of the builder functions. There's another function for building data frames, another one for building matrices. Any other questions?
Is there a way you can see how much missing data?
Yeah, I actually meant to do that. Good call. So the is.ina function will tell you whether what you put in is true or false. So if I put in just ina, or sorry, it'll tell you if something's missing or not. So if I put in ina, it's true, right? If I put in is ina letters, I'll get a bunch of falses. Now, normally we could just put in births, but in this data set, I know that 99 is the missing code and not ina. So what you would actually, in general, I would say is.ina, births, $jest, and that would work. But for this data set, in real life, I would convert the 99s to missing, but I would actually do something like table. So first I would say, okay, births, $jest, double equals 99. Okay, so step one. Well, okay, step 0 is get the variable to print. All right, great. Next step is see if it's equal to 99, which is the missing code in this data set. All right, so I've got maybe some true falses. And the next step is to make a table of this. And so there's 124 of them that have 99. So there's 124 missings in the data set. So it's like building from these basic building blocks. You can get to a lot of different stuff. Basically, each function that you know, you can then also include all the other stuff you know, and it kind of builds exponentially. If I wanted to recode this, I would just use the assignment arrow. I would say, this is going to be confusing, but just as an example. So let's say births just where births just equals 99. Okay, so here instead of making a table, I'm saying subset to all of the ones where it's 99, right? So if I run this, I get a bunch of 99s. Now this is the thing that's confusing if you're not used if you're used to SAS. You can actually overwrite anything you want, including built-in functions, including the value of the number 1. Don't do that. Including what plus does. It's called overloading an operator. I can just basically, now that I've referenced as part of my data, I can overwrite it. So I'll say, I'm going to save, this is backwards, right? I'm not making an expression and saving it to a variable. I'm basically writing the expression on the left and putting in something very simple on the right. So I'm saying, look up these positions, and instead of printing them, replace them with missing. So if I run this, doesn't say anything. But now if I make a table of is this missing, all right, I get the same thing. And now there's going to be no 99s to show you. They've all been replaced. So this will be the essence of the 3 data management lectures, is how do you wrap your mind around overwriting parts of the data set with other things. So at the end of the class, you'll be writing complex expressions on both sides to do really complex data management things in one line. And it'll make sense to you and other people that use R. But will be confusing if you just look at it with no background and you're like, what's going on? Yeah?
So is that permanent overwriting?
Mm-hmm. Well, I mean, this is basically overwriting this copy of births. Like, it won't change my CSV, but yeah, it's basically permanent until I quit R kind of thing. Yeah.
Oh, so like if you mentioned like if you overwrote the value of 1, for instance,
Yeah.
it would stay that way until you close it.
Yeah, you would close R, don't save, and then open it up again.
Okay.
Yeah, before your computer explodes. I mean, it's not too bad. Like, I can overwrite the value of plus here, I think. Let's see. See what happens. Okay, well, there's some way to overwrite what plus does. It's actually plus is this, I think. Let me see if I can break my computer here. Yeah, there we go. Okay, so now I've overwritten the value of plus. So if I say plus minus plus, oh god, okay, this is going south. Okay, well, you get the idea. I could write an expression now and it would treat plus as 1. Yeah.
I would suggest once when you start working with a data set, you're ready to R, you actually
Mm-hmm.
So whatever mistake we made for that one, we'll put that.
Yeah, so I do like, work is bursts, and then I would work with the work data set or something. So you can always reference your original. How do I... Let me see if I can actually get out of this loop. Try plus minus. Let's try plus times plus. But I mean, that's based. Any other questions? Yeah.
The tables function, is there a way, if you had values of data that were already, R was already treating it as an R missing value, or you had just recoded it, can like the number of NAs then show up in the summary?
So I'll just show you really quick, and this will be sort of jumping ahead, but I've only shown functions that only take one thing on the inside, like sine, cosine, you put one thing in. You can actually add, the way you add options in R is by commas and then equal signs. So I would do table of births, $, jest, comma. So I've got more things I want to tell R. Kind of like this is saying I've got more indexes to put in. And I'll say use .na equals true. I believe that's, let me see what it actually is. It's either use NA or NA action or something. Let's try that first. So I can tell it, oh, it's going to be always, hold on. Let me just look up the help page. So if you do question mark table, I can look up the help for table, and I'll see that the argument I want is called use NA. Again, we'll review this in the future, but use NA equals always. Oh, wait, see details. Okay. Use NA. Both exclude. Okay, where is it? Let me just try always. Okay, so here I've said, okay, always show the NA values in the table. So now you can see there's 124 missings in the bottom. So this is basically how you do options in R, is by this little individual assignments within the function. Good question. Anything else? Yeah.
Sometimes I see people type in that area.
Oh, yeah.
Sometimes there.
Yeah, so you can. I mean, basically, all that happens when you type over here is if you run something, it feeds it into the thing on the right. I mean, it's usually just easier to write a script, but if you just want to do something like a one-of thing, you can just type over here if you want, like, what's the mean of, burst, $, jest. The other nice thing about the terminal is if you press up on the keyboard, it'll cycle through everything that you've run before. So you can, like, if you want to try and rerun something, you don't want to find it again, you can just cycle through the recent history. Good question. Anything else? All right, well, I think we're a little bit over time, so thanks for your attention, and I'll be here for a few minutes if you have any questions until I get kicked out by the next class. Oh, you can click maybe clear. Oh yeah, is it Control L? Yeah, it's Control L. And then you can clear the environment with this thing, but there's also a hotkey for that. I don't know what it is. Let's see if there's any. Yeah, I guess you just click the little thing.